Hello everyone, how's it going? And hope you're fine. Today I'll show my first task with the Sparks Foundation Internship Group November, predicting using supervised machine learning. Supervised machine learning depends on your data, if it's numerical or category. Okay, so we have two types, regression and the classification. And today we have numerical data, so we will go for regression. We are gonna predict the percentage of a student score based on his studied hours. Here's my domain with the internship, data science and business analytics. It's my name. Okay, I'm using my repo, my GitHub mail. Okay, let's go. Here's the link of the given dataset. First, I imported my essential libraries that I will use. Extracting the data. Here is the data. Hours and the scores, which is in float type, and the scores in integer. As you see, we will check it again. We will go to understand our data and check if it is clean and so on. Here is the shape to 25 rows and 2 columns. Here is the type, float and integer. I checked for the duplicated values in the data and I got 0. Also the null, I got 0, which is good. I was taking a look with detail. I was described with some descriptive statistics. As you see, the mean of the hours is 5 and the score mean 51.4%. Let's go with some graphs, checking the distributions. Here is the histograms, and I use it in numbers, checking the skewness, and I got 0.19 and 0.23, which is close to 0, so all is good. And I use some graphs here, checking my distribution tool, kind density. Okay, here is a plot in the blue color hours and scores with orange color. As we see, it's like normal distribution. Here is the main graph you will need if you are gonna use regression, linear regression. Okay, here's the plot, describes the relationship between them, score percentage as y and start hours as x. Okay, so it gives us there is a clear and highly positive regression between hours and the scores. You can check it with numbers using dot correlation. Here's the scores and the hours 97.97, which is high. You can get it with heat map as a graph too. It's approximately 98. So we're gonna split and train our model now using x and y. Let's train this split function, linear regression, and fitting our model. Here is a regression plot. There is a line and the values around it. X test as an array, checking it. And there is Y predict. Okay, we will save our predictions in Y prediction. Okay, there's output, and now we are gonna make a comparison between the actual values, which is Y test, and the prediction, which Y predict, that we saved here, and we got, as we see, 20 as an actual value, and the prediction is 16.8, and we can check each one of them. You can check it using graph like that here, the bar, kind bar, and the orange color for the predictions and the blue color for the actual value. We are gonna now for evaluating our algorithm linear regression using some measurements like R-square, mean absolute error, and mean square error. And we got 9.93 as R-square, which is very good. Okay, it describes the quality of your model. Here's MAE 4.13 and mean square error 20.33 and approximately 20. Here's the question: what will be the prediction if a student studies 9.25 hours per day? And we can change it and try it if we want. Here's the study hours, okay, and the predictions that we got is 93.8 as a percentage for the score, which is good. Like if the study hours increased like 10, we will get like 100 and more. Thank you for watching.